Hi guys, this is the video for lesson 24, session 2, and it begins on page 507. So this is just day 2 of multiplying fractions by whole numbers. Remember, this lesson is only 3 days, so only one more after this. Alright, let's read our blue problem there about cookies. Yum. James is baking cookies. One batch of cookies uses 2/4 of a teaspoon of vanilla. James wants to make 3 batches of cookies. How much vanilla does James need? Okay, so I'm going to draw a model to begin. If you guys want to do this problem on your own, though, that's what we would normally do in school. So model, number line, you can go straight to an equation, whatever you like, or you can follow along with me. So I'm drawing 3 models to represent the 3 batches of cookies. And then I'm going to break each one up into 4 equal parts because it is fourths. Okay, and it said he uses 2/4 of a teaspoon of vanilla, so 2/4 for each batch of cookies. Okay, so there's 1 batch, 2nd batch, 3rd batch of cookies. So how much total vanilla does he need? So it's 2/4 plus 2/4 plus 2/4, or 3 batches times 2/4. So my denominator stays the same. It's going to stay 4. And then I do my whole number, 3 times my numerator, 2. 3 times 2 equals 6. Okay, so he needs 6/4 teaspoons of vanilla, but we also know that there's a whole number hiding in there, so you can say 6/4, or you can convert it to a mixed number. So 6 divided by 4 is 1, denominator stays 4, 6 divided by 4 equals 1 with 2 remainder. Okay, so if I took that 1 whole out and put it here as my whole number, I took away 4/4, I'm left with 2/4. So he needs 1 2/4 teaspoons of vanilla. Okay. And that's it. So turn the page, we'll answer some questions about that problem. Okay, on 508, it shows a couple different ways to solve it. In this part, they show the little teaspoon pictures. So each little picture, each model, every little spoon, I guess, is 1/4 of a teaspoon. TSP is short for teaspoon. So here's 2/4, 2/4, and 2/4. So altogether, you can see that there are 1, 2, 3, 4, 5, 6 fourths. You can also do a fraction bar model like what I did, but mine were just vertical instead of horizontal models. First batch, 2nd batch, 3rd batch, and then if you add up all the red or orangish little fourths, there are 6 of them, so 6/4. Okay, let's answer some questions about it on 509, the connected side. Okay. Number 1, how much vanilla does James need for each batch? So for 1 batch of cookies, he needs 2/4 of a teaspoon. Okay. Number 2, how many batches does James want to make? That was 3. Number 3, write an equation to find out how many teaspoons of vanilla James needs. Number of batches was 3. Teaspoon for 1 batch, so how much for each batch was 2/4. We already solved it. We know the denominator stays the same, and 3 times 2 equals 6. Number 4, explain how you can check your answer using repeated addition. So you can add 2/4 plus 2/4 plus 2/4. Okay, you do it 3 times, right? That's 3 times 2/4, 3 copies of 2/4. 2 equal 6/4. That's how we check our answer with repeated addition. Number 5, write the fraction that shows how many teaspoons of vanilla James needs as a mixed number. So 6/4 really equals 1 2/4. We already talked about that. Number 6, between which two whole numbers of teaspoons is the amount of vanilla James needs? So what this means is if I have a number line 0, 1, 2, 3, we'll go to 4. As whole numbers, where would 1 2/4 be? Okay, so if I'm breaking it up into fourths, there's 1/4, 2/4, 3/4, there's 4/4, it's 1, 1 1/4, 1 2/4. Okay, so here I am at 1 2/4. Which whole numbers is that between? Is it between 0 and 1? Is it between 1 and 2? Is it between 2 and 3? Or is it between 3 and 4? Okay, so obviously you should be able to see 1 2/4 is right halfway between 1 and 2. Okay, it is between 1 and 2 teaspoons. Okay. Number 7, how is the fraction bar model like the teaspoon model in showing how to multiply a fraction by a whole number? So it's just asking on the previous page, the blue little spoon picture and the model picture, how are they the same in showing how to multiply fractions by whole numbers? Okay, so basically both models just show 3 batches. So we'll say that. Both models show 3 batches with 2/4 in each batch. Batch of cookies. And they both show a total of 6/4 teaspoons. Okay. Number 8 is a reflect question for you to do on your own. Figure out which strategy you like the best. Do you like pictures? Do you like fraction bars, number lines, equations? What's your favorite strategy? Tell me what it is and explain why. Okay. And then turn the page. We have some apply it problems, so you're going to apply what you know about multiplying fractions by a whole number to solve these problems. Number 9, Micah jogs 8/10 of a mile. Sarah jogs the same distance 3 days in a row. How far does Sarah jog altogether? Okay, so Sarah jogged for 3 days. Each day she jogged the same distance, so 8/10 of a mile. So 8/10 of a mile 3 times. So altogether, how far did she run? Denominator stays the same. I do my whole number times my numerator to get my new numerator. 3 times 8 equals 24. But then I need to divide and figure out, because there's a whole number hiding in there, right? There's actually a couple whole numbers hiding in there. 24 divided by 10. 10 can go into 24 2 times. Denominator stays the same. What's my remainder? Well, 10 times 2 is 20, so 24 minus 20 is 4. 24 divided by 10 is 2, remainder 4. So she jogs 2 4/10 miles. Perfect. Number 10. On Monday, Sylvia spends 5/12 of a day driving to her cousin's house. On Friday, she spends the same amount of time driving home. What fraction of a day does Sylvia spend driving to her cousin's house and back? Okay, so she drives or spends 5/12 of a day driving there, and then she drives back later. So she made the drive 2 times. 2 times 5/12. My denominator will stay the same, 12ths. Whole number times numerator. 2 times 5 equals 10. So the fraction of a day she spent was 10/12. So she spent 10/12 of a day driving. Driving to her cousin's house and back. But I ran out of space. That's it. Okay, last one. Number 11. Isabella from our class fills her fish tank using a water jug. The water jug holds 4/5 of a gallon of water. Isabella uses 9 full jugs to fill her fish tank. How many gallons of water does the fish tank hold? So she fills that thing 9 times. Each jug, the water jug that she fills, holds 4/5 gallons of water. So what's the total amount of water? So there's my equation. My denominator will stay the same. And 9 times 4 equals 36. But 36/5 is not an answer because it's really going to be a mixed number. There's whole numbers hiding in there. So what's 36 divided by 5? How many times can 5 go into 36? 5, 10, 15, 20, 25, 30, 35. That's as close as I can get to 36 without going over, right? So that was 7 times. My denominator will stay the same. And what's my remainder? Well, 36 divided by 5 was 7 because 5 times 7 was 35. 36 minus 35 is 1. I had 1 remainder. 7 1/5 gallons is C. Ta-da! Okay, now it's time for the practice pages. If you want to pause the video and go through and try them on your own first, and then just use the video to correct your answers, that would be perfect. If not, let's go through and do them together. Okay, number 1 on page 511. Benson spends 5/6 of an hour reading each day for 3 days. How long does Benson spend reading this week? So we just need to solve the equation in the first boxes there, and then we convert it to a mixed number. So here's 3 times 5/6. They already set up the equation for me. I just need to solve it. 6 is my denominator, so it's going to stay 6. Sorry, just a sec. I'm watching one of my cats pester my chickens outside. He's being a jerk. Well, they're fine. Okay. Anyway, let's cover up. I'll use flat Mrs. Flitton to cover up the rest of it. Okay, so my denominator stays 6. Now I do my numerator. My new numerator is going to be my whole number times my numerator. So 3 times 5 is 15. Okay, now I can convert 15/6 into a whole number plus the fractional part, because there are whole numbers hiding in here because my numerator is higher than my denominator. So 15 divided by 6. 6 can go into 15 2 times. My denominator stays 6. Okay, here's my fraction bar. 2 times 6 is 12. 15 minus 12 is 3. So 15 divided by 6 is 2, remainder 3. So we could say Benson spends 2 3/6 hours reading. Done, done. Okay. Number 2, show how to use repeated addition to check your answer. So it was 3 times 5, 6. So we're just adding 5, 6 3 times. 5, 6 plus 5, 6 plus 5, 6. Denominator stays the same, 6, and 5 plus 5 is 15. Checked. And a star. Okay, number 3. Sabrina rides her bike 3/4 of a mile. Katrin, I think, rides her bike the same distance on each of 4 days. How far does Katrin ride her bike altogether? So she rode 4 days, 4 different days. Each day she rode 3/4 of a mile. Okay, so there's my equation. My denominator stays the same, going to be 4. Now I do my whole number times my numerator. 4 times 3 equals 12. So you can say that she rode 12/4 of a mile, or you can convert that to a whole number or mixed number. So 12 divided by 4. How many times can 4 go into 12? Well, that's just 3. No fraction left over. There's no remainder, right? 4, 8, 12. So 12/4 is just 3 miles. That's my answer. Ta-da! I keep saying ta-da. I don't know why. Okay. Next page. Last page. 512. Okay, number 4. Jorge coaches soccer for 1/12 of the day on Saturday. That day he also coaches tennis and swimming, each for the same amount of time as soccer. What fraction of the day does Jorge coach on Saturday? Show your work. Okay, so we know the fraction part of the equation is 1/12, right? He coaches soccer for 1/12 of the day, but he also coaches tennis and swimming for the same amount of time. So total coaching, how much time does he spend? But what do I multiply by? I don't have a whole number, right? So what sports does he coach? He coaches soccer, but he also coaches tennis and swimming. So those are 3 different sports he coaches. Each one he spends 1/12 of the day coaching. So that's my equation. That one was a little bit hidden in there. So my denominator stays the same. Whole number times numerator. 3 times 1 equals 3. So that's it. He spends 3/12 of the day coaching. Star for your work, star for your sentence. Number 5. Greta plants flower seeds in 12 pots. She uses 2/6 of a bag of flower seeds in each pot. How many bags of flower seeds does Greta use? Show your work. Okay, so she has 12 pots, and each pot gets 2/6 of the bag of flower seeds. That's a lot. So there's our equation. My denominator stays the same. 12 times 2 equals 24. So there are definitely whole numbers hiding in there. 24 divided by 6. How many times can 6 go into 24? Well, it's just an even whole number. It's 4. 6 times 4 is 24, so there's no remainder. There's no fraction part. It's just 4. So she uses 4 bags of flower seeds. Star for your work, star for your answer. Okay, and number 6 and 7 are about this blue problem here. So it says, Leslie practices the flute for 2/6 of an hour 3 times this week. She practices piano for 2/3 of an hour 2 times this week. Which expressions can be used to show how much time Leslie practices both the flute and the piano this week? So it says expressions, more than one, so there's going to be multiple. Okay, so for the flute, it's 3 times 2/6 of an hour each. So that's for the flute. For the piano, it's 2 times in the week for 2/3 of an hour each time. So this needs to be in our equation somewhere, or repeated addition, right? Because that's the same thing as saying 2/6 plus 2/6 plus 2/6, and this is the same thing as saying 2/3 plus 2/3. Okay, so I see it right here. They're adding just both of them, the multiplication equations. 3 times 2/6 plus 2 times 2/3. So definitely an A. How about B? 5 times 2/6 plus 2/3. So this is the times that she spent practicing and the total number of days. But that wouldn't work. I'm not adding those fractions and then multiplying it by the days of the week. So that doesn't work. Here's all the repeated addition though. All the 2/6 each day that she does 2/6 of an hour for the flute, and the 2 days that she does 2/3 of an hour for piano. So that one works. For E, they switched it. See, it's supposed to be 3 times 2/6. They did 2 times 2/6. And then it's supposed to be 2 times 2/3. They did 3 times 2/3. So that doesn't work either. Okay, and D. Interesting. So this one looks very strange. This does not look like anything we've done before, but really all they're doing is kind of simplifying the problem. Because if we take this one, for example, 3 times 2/6 equals blank. So my denominator stays the same. It's going to be 6. Like here, it is 6. But then I'm just multiplying 3 times 2 to get my numerator. So in the numerator spot on this fraction, it's 3 times 2, which would be 6, right? So that's all they're doing. They're just kind of smushing it all together on top of the numerator line because the denominator stays the same. So D is actually a correct one also. It's just the whole number times the numerator in the new numerator spot. They're just kind of combining steps. Okay, so it's just those 3, so 3 stars. And number 7, which does Leslie practice for a longer amount of time, flute or the piano? So longer amount of time. Oh, I didn't mean to cross it out, I meant to underline it. So which is going to be the greater fraction? So let's do both flute, and then we'll do piano for here. Need to solve both of them. So the flute was 2/6 of an hour 3 times a week. So that's my equation. 3 times a week, 2/6 of an hour. And then piano was 2 times a week, 2/3 of an hour. Okay, now I can solve them. Denominator stays the same, and 3 times 2 equals 6. So 6/6 really just equals 1. So she practices the flute for 1 hour. Okay, piano over here. Denominator stays the same, it's going to be 3. And then my whole number times my numerator, 2 times 2 equals 4. But there's a whole number hiding in there. So 4/3 is really 1 whole and 1/3 left over. So what's greater, 1 or 1 1/3? 1 1/3 is greater. So she practices the piano longer than the flute. Star, star, star. All right, that's it. The next day, session 3, is your refine day, the last day of the lesson. So try those ones before you watch the video, please. See you then. Bye, guys.